Good morning. Can you hear me? All right. So, talking about white box. Why am I here? To share an open networking experience from an enterprise perspective. I noted non-hyperscale there because I think it's very different for a typical enterprise to put white boxes in their network. You know, we're not Facebook, Google. We don't have an army of IT engineers to build code or write their own thing like Sonic. So a little bit about me. My company, I work at Qualcomm. We have 30 plus data centers. About half of those are actually considered server rooms because they're tier 1 or 2 data centers, not the tier 4 like the better ones. Lots of data center switches, mostly spine leaf topology. And we have a dedicated net DevOps team. So more on that later, but we're very lucky to have a team of developers, about 7, that write custom tools for us for self-service type automation. What is open networking? It kind of depends on who you're talking to, who your audience is. For us, open networking is basically white box or bright box with ONI and software on top. So for us, we've tested many different things. You hear me talk mostly about Cumulus and Big Switch monitoring fabric. We've also tested OpenSwitch, Sonic, and Junos on white boxes, just to make sure everything works and have a backup. So why open networking? It's one of the obvious drivers is cost reduction. You can save a lot of money by doing open networking. That's initially why we started looking at open networking at Qualcomm. We wanted to see what was out there. A few years ago, we started paying more attention to finance, and this was an easy way to potentially save a lot of money. Disaggregation is another one. So we settled on Big Switch for a monitoring fabric. We see it's a packet replication network, and Cumulus for networking, but that can change. So if one of our favorite vendors gets purchased by another large vendor, swallowed up, and they discontinue the product, we can shift and run different software on top. Hopefully that doesn't happen with these two. Then this, Linux is easier to automate than Cisco, Arista, Junos. I might be a little bit biased when I say this. I started out with Ansible on Linux, more of a server type of automation, mostly just file copy type operations. And it's very, very simple, very easy to use. And we then started using Ansible on Arista, Cisco, and other things. There's a little bit more of a challenge. So with these tools that were built for Linux, using them on a Linux platform like Cumulus or OpenSwitch is just a little bit easier, in my opinion. But I have a picture there of some cattle versus pets. This is a server term that doesn't exactly translate to networking, but I use it to try to illustrate a point with my engineers and my team that before we would have very, very special switches, and we would log into them, we would know them by name, and we would config T them and put all of our special config on there. Maybe we had our own special shortcut commands on there, and we would memorize the name of the switch. Well, when you make a change like this to open networking, it's very easy to go from that mindset to a cattle mindset where you're using Ansible to basically, or Puppet Chef, whatever your flavor is, to push out this configuration, and you no longer need to keep track of the switch name. Oh, that's my special switch in that data center that I always look in. They're all the same, and you can basically use automation for configuration and show commands. So it's a different mindset. And it's Linux, open Linux. So we'll talk more about specifics of our boxes, but one thing I really like about it is it's basically an open Linux platform. Arista lets you get into their bash and you can do a few things, but you can't just install whatever you want. So with open networking, it is open and allows you to do whatever you want to do, which is great for us. So how did we start? We didn't just start by throwing in some white boxes straight into our data centers. We did a lot of lab testing. So about a year of lab testing, I think. Tested a lot of different vendor products, bought some trial licenses, opened some TAC cases with a few vendors, talked to a lot of SEs, and settled on Cumulus for networking and Big Switch monitoring fabric for packet replication network. It's a little bit out of order because we started with Big Switch. We had a very expensive NUI network, packet brokering network, packet replication to security tools, things like that. And the time came to renew the bill, and I was like, wow, look at this. I'd never gotten one of those kind of renewals before. And basically, for the price of renewal of like 3 or 4 boxes, we were able to purchase a completely new BMF network, all the switches, the software, everything. And it's actually easier to configure and control. It's basically OpenFlow underneath and uses a controller. So we replaced a whole NUI network with Big Switch. Hopefully nobody's in here from a NUI. Sorry about that. But it just works. So did that. That was running for about a year or so. And in the meantime, we were testing Cumulus and a few other things in our labs. And we decided, OK, let's try it out. So we started out with some basic copper installations, which I'll show in a second. Saw some cool features. I mentioned the OpenFlow for big monitoring fabric. It's also, when you bring these boxes up, it's a heck of a lot easier because you basically start off with ZTP type functionality, zero touch provisioning, and DHCP to load software. So you don't have to run around with a console cable and plug in like we used to do. Basically use the network to bring these up, if you're lucky enough to have an out-of-band network, that is. And Cumulus, if you haven't checked them out, they have some pretty cool network features. BGP unnumbered is a great one. I mean, how come we haven't done that for the past 10, 15 years? There's some other ones in there that are exciting, maybe not for everybody, but for certain environments, very useful. So what about hardware? We started off with Acton Edge Core hardware because most of our vendors, it seemed most of their development was going that way, and they had a lot of different boxes on the hardware compatibility list. Those worked well for both vendors. We recently made a move to Dell for a lot of reasons. One of mine was basically snap-in rack rails. I heard that on a podcast. I'm like, wow, how come we don't do that? We've been doing it with servers for years. So they're great. They show up, no screwdriver, you just pop them in. The quality is a little bit better as well. And whenever we buy switches, we make sure that the model is on both of our vendors' hardware compatibility list. So we stock spares. We don't actually buy hardware support. And if something dies, we just swap it out. Whether it's Big Switch or Cumulus, you just swap out the hardware, and the license is basically a license. It's not tied to the box. Optics and cables, basically everything we've tried works. That's another area where we've saved a lot of money. And then underneath, it's the same chips and Intel CPUs and basically everything. If you get in an Arista switch and do LS, PCI, same thing on one of these white boxes, it's all the same hardware underneath. And that really helps because we know the performance of these, Trident 2 or Trident 3 chips. As I mentioned, we weren't able to just throw these boxes in and start going because there's very different architectures in both cases. With the Big Switch monitoring fabric, it was actually really easy. We just put the boxes on the network, a little bit of DHCP, pull their software from the controller, you point them to the controller, and everything else is done from the controller. So those are easy. So most of the rest of what I'm going to talk about is focused on Cumulus and how we do the zero-touch provisioning and the initial configuration of those boxes. So as I mentioned, zero-touch provisioning is the way to go. Those things boot up in ONI, Open Network Install Environment. They look for a default URL. You give them a default URL, and they just come up on the code version that you want. It's great. We store everything in GitHub. You have to do this. If not, you'll end up with engineers with different code and different ZTP scripts on their laptops. Nothing matches up, and it's just chaos. Then we use Jenkins for basically a centralized point to run our Ansible playbooks from, and you'll see why here in a minute. And then we use Ansible. A lot of the other developers in our company use Ansible. I've gotten a lot of help from them as far as building this architecture. There's a lot of examples online, and it doesn't require agents. So when we started with Ansible for Cumulus, but then we were able to move it to Arista, Citrix a little bit, and some other platforms. So here's a picture of what that framework looks like. As I mentioned, we started it out for Cumulus. Basically, I don't know, has anybody ever configured a Cumulus switch or an OPX switch? A couple people. The first time I did one of these, I sat down and I opened up VI and I built out the resolve.conf and the ntp.conf and the ports.conf. And I did that one time and I said, never again, I'm not doing VI every time. My engineers would just rebel, they wouldn't do that. So that's when we started looking at how we're going to do this, how we're going to configure these things in mass and then have our configuration stay true to what it should be. So basically the source of truth is in GitHub for our configurations. And then like I mentioned, we use Jenkins for the central point from which to run these playbooks. And there's a lot of reasons for that. You could look at Ansible Tower. There's a few other things out there. This one we have a lot of Jenkins experience at the company again, so a lot of people are using it. We have tie-ins to Splunk, so it tracks who ran a job, when it was run, what the output was, and then you can search through Splunk for that output. So if you want to see what happened when and who ran this and who made this change to ntp.conf, it's all there. It's great. It also gives us a centralized place to run these playbooks from. So early on, I saw, these playbooks are great and we can do Ansible and this and that, but if we just end up with playbooks on everybody's laptops, it'll be just like our initial config scripts on everybody's laptops, and then maybe this guy has his own name in there, he has a local user account, and then this one has these shortcut commands, and everything kind of gets configuration stray. So having everything in GitHub and then running all the playbooks from one place kind of guarantee that we're tracking what's run where, and this is a big part of our automation because if you don't have this, things can kind of get out of control quickly. Another thing is that Jenkins Ansible server or servers is in a special subnet which has access into DMZs and certain other areas in our network, so it's a little bit easier to do security. And basically that Jenkins VM is just a VM. It doesn't have any Ansible plugins or anything installed. I know it says that in here, but we just installed Ansible on there. We try to keep it very simple, so if the VM blows up, I can just build another one and keep chugging. And it's great for other things like cron jobs. We want to run something once a day. Very easy to do. So what do we automate? Almost everything. So this is in regards to our open networking, specifically Cumulus. We use ETP for bring up, like I mentioned, Ansible for the initial configuration. So we push the global config onto the switches. That's your resolve.conf, ntb.conf, ports.conf, all those things I mentioned. It also restarts the services after it pushes those files. And we have an API for user self-service, GUI, and I have some screenshots of that. That's our day 2 automation. That lets our users, our team that does the rack and stack of servers actually go in there and change VLANs and do all that sort of thing. So they're not putting a request with us and waiting for our SLA of 2-3 days, whatever, to change a VLAN on a port. And then we also use Ansible for global configuration compliance. This is a new one that we've just started doing. So we have audit requirements. Anybody else have audit requirements? You have to comply with audit? Yeah, I know you do. So it's a lot easier to just basically declaratively say once a week, once a month, whatever, here are all your NTP servers. Is your syslog configuration. Here's your TACAX configuration. And then push that once a month, once a week, whatever. And you get that feedback of if something's okay or if something changed. And it's a lot easier than auditing, hundreds of switches and then looking through the results and then trying to go fix everything. So it's a lot easier for us to do that sort of thing on a greenfield environment like Cumulus Whitebox. I definitely realize that. And then a note down there, do automation day 1. So if you are thinking of doing this, or if you're working on it in the lab or anything, definitely incorporate automation day 1 as part of it. You don't want to start something new and then basically just fall into the old ways of config T everything one at a time. This is a great opportunity to basically change the way you do things. So some examples, zero-touch provisioning. This is for Cumulus, and it's very easy. It's just the default URL. You point it at we use a web server. The switch will boot up. It's in ONI mode. It DHCPs out all of its interfaces. We plug in the management interface to our out-of-band management network. Pulls an IP address, DNS server, default gateway, and a default URL. Then it goes to that web server, pulls down the code, reboots, and voila, you have a Cumulus switch. One thing I didn't include on here is reservations. We actually do MAC address reservations per switch. So when we we'll either grab the MAC addresses from the switches before we send them out to the team to mount them, or we just send all the switches to the team that mounts them. They tell us, hey, switch 47 is going to be MAC address, ABCD. And then we do a MAC address reservation for that so that we know when that switch comes up, it's already got its right name, correct name and everything, and we can just push the automation towards it, whether it's a leaf or copper switch, spline, that sort of thing. So once the switch is online on the network, we've already zero-touch provisioned it. It's there. We can ping it, SSH to it, whatnot. Then we'll run the Ansible playbook to push down that global configuration. Additionally, for these switches, we're pushing the leaf configuration. So for Cumulus, we'll do a leaf set of 2 switches, and they do their MLAG thing, and they run BGP, and they always have their own local /24, and then they have /32s, whatever the case is. So we put all that in variables. I'm not showing that on the GitHub picture there, but it's all there. And then there's a screenshot of Jenkins, which we use to run the playbooks from. And if you haven't used Jenkins before, basically what it does, all it's doing for us, is it's pulling down that playbook from GitHub and running it. So every time we make a change in GitHub, we can basically just pull it down and run it. In fact, one of our other playbooks auto runs, it uses a webhook from GitHub. So if you change something in the repo, just change the host file, it'll auto run and email you results from whatever show commands you wanted to do. And at the bottom there is just an example of successful Ansible. But this one is actually provisioning 2 switches. Day 2 automation. Like I said in the beginning, we are very lucky to have a dedicated team. I think we have 7 or 8 engineers now that basically do nothing. Well, they do a lot of things, but one of the main things they do is build our Day 2 automation tools for us. And they use whatever language they want, and they use whatever GUI they want. But very useful tool. This one right here, this is a screenshot of one of our tools that our rack and stack guys used to change VLANs on ports. So it used to be that they would rack and stack, a couple servers in a rack, and then they would find some open ports in a switch and go plug it in, and then say, hey guys, can you please put these on VLAN, 2 or whatever the case, or trunk or VPC or whatever it is. And then they, would go through our ticketing process. A couple days later, that would happen. Well, now they can basically go into this tool and make those changes themselves. But we have a lot of safeguards in place. So the red ports are the ones that are down. And with this tool, they can only make changes to down ports. So they know that. And before they plug in the server, they'll make the change, put the the right VLAN or whatever it is description on, and then plug it in. And it comes up, and they don't have to wait for us to do that configuration. So. Very lucky to have that team. I do not take them for granted. So this wasn't easy. It's still not easy. I mean, we're at the point now where I think we have about 50 or 60 switches in production. Another 10 or 20 in our lab for testing. Wasn't easy to get them online. There's quite a few obstacles to overcome. One of the big ones is where's my config T? So I have a team of 8 engineers in San Diego that supports data center networking and load balancing, and really sharp guys, been doing this a long time. There is no config T on these switches. It's basically Debian Linux for Cumulus anyways. And so it's very, very different. You go from having one file to manage to configuring a whole bunch of different files, restarting processes, basically Linux net sysadmin. But they like it. They enjoy a new challenge. It's something very different from what they've been doing for the past 10, 15 years. So most engineers are pretty excited to learn something new. So this is the second bullet. I showed this to my director last week. He's sitting back there. And he said, hey, you threw me under the bus. And I said, no, this is definitely not throwing you under the bus. This is a valid point I wanted to bring up. I'm very lucky. My director is a triple CCIE, and then his boss is also CCIE. Very sharp guys. They know networking inside and out. Lucky to have them. But one of the first questions is, who do I call for support? So there's a software vendor that rides on top of the hardware, and then there's a hardware vendor. Well, who do I call if a box dies? So if you've been doing Cisco or Arista or Juniper for the past 15 years, you just call their tech, and then they deal with it and they send you. On the server side of things, we've been doing that, the software and hardware way for a while now. So it's just a matter of basically shifting gears. I can tell you from experience, I think we've had 2, maybe 3 RMAs of boxes, no Dells yet, But those were very, very easy to deal with. I think those were all DOA. One switch just was dead, and another one had a bad console port, and we just called up Cumulus and said, hey, we think we have bad hardware. They gave us a few commands to run. Yep, it's bad hardware, and then we went back to our vendor that we bought it from, I think it was HP for those, and said, hey, we have bad hardware. The new switch came, you went back, no questions asked. So haven't heard any horror stories of a software vendor pointing at a hardware vendor and saying, no, it's their fault, and causing problems. But it is something that you have to identify day one. It's very different. Legacy network management. So these are Linux boxes, and we have Linux monitoring tools for our servers, but this is a network device. So we still have to use a lot of our network tools. We use RSA for login, ACS, that sort of thing. SNMP, looking at interface queries. So it mostly all works. Some of it was a little challenging to set up at first, but it all works. But then you can start doing things a little bit differently as well. So you can store configs in GitHub Jenkins rather than a config repository like HPNA Opsware. So our plan for if a switch dies is not take the switch configuration that was running 24 hours ago, one big file, and slap it on the RMA switch. We basically just put the new switch in, zero touch provision it, push the global config on, and then really the only thing that makes that switch unique is the Etsy network interfaces file, maybe the ports.conf, quagga.conf. So we back up those specific files once every 24 hours, and we just keep them in the Jenkins server. So a little bit different way of doing things. And I've already kind of mentioned this, but change in mindset from a single configuration file to Linux netsysadmin. But at my company, I don't know if anybody else's company is running OpenStack or Kubernetes or anything like that. I mean, this is worthwhile knowledge to have. If we're all going towards this, Linux networking approach and more exposure to that as we're dealing with things like Calico and Kubernetes, we all need to know a little bit of Linux networking. So it makes sense to learn it, and this is a great place to do that. So where did we start? Like I said, we started in a lab for about a year. Still working in the lab, still testing a lot of things. Like right now, we're testing VXLAN and interoperability with other vendors. But where did we start deploying? We started deploying in the out-of-band networks. So our data center out-of-band network, that's our out-of-band for our switches. Non-critical environment, easy place to deploy something that if it crashes, not that big a deal. It's just kind of a backup network anyways. And then we just started deploying in server out-of-band networks, so the ILOs and that sort of thing. Very low risk, but we can get the switches out there, and we could have them in monitoring and start to learn what to look for, learn things in syslog, when to alert on whatever errors, things like that. Get to know the vendor tech. And then lab test dev environments. So this is what my team would consider production, but other business units consider lab test dev. So we deploy to those environments. Some LAN access, we've tested PoE, that works well. And then a simple critical environment, we run a HPC grid to develop all the chips for all your phones and modems, things like that. And that requires a lot of compute. So one of our high throughput tests was basically a pair of 100 gig leaf switches hanging off mostly Arista network, and a stack of servers all connected at 25 gig just to measure raw throughput and LACP, MLAG, things like that. Test network. You definitely want to have a test network. We have a large lab. It's basically a small data center. Very lucky to have that, I know. So we have lots of things deployed in there. We test everything in the lab before we put it into production. We also use VirtualBox quite a bit, and Vagrant makes it really easy. We can have a Vagrant topology stored in GitHub, and any engineer can just download it and run it, and now they have a built-out Cumulus network they can test out. Lessons learned. I'm going to zoom through the rest of these so we can have some Q&A time. Adoption can be tough for seasoned network engineers, but as I mentioned, a lot of the older engineers have been doing this for a while, like this challenge of something new. It's very, very different, and like I said, it's a bridge towards other Linux networking that they might be exposed to. Cattle instead of pets, talked about that. Switch VMs are great learning tool. That's a picture of a Mac with some switches on there. So we have a topology like this that you can just download and Vagrant up, and then you have 4 switches connected in that way. You have an Ansible VM off to the side, so we test a lot of our automation before it goes into production and things like this, or we'll test it here, then we'll move it to the lab, then we'll move it to production. So in conclusion, enterprises can deploy these and save money and usher in the new era of Linux networking, I like that saying, as long as you basically keep an open mind. Open networking requires an open mind. So this is a pets versus cattle picture I found on the internet. Any questions?
Hi, my name is Irfan from Bloomberg. We are doing exactly what you guys are doing, so I can actually relate to that. One question that I had, you talked pretty much about your automation team. How do you bridge the gap between software developers who are not network engineers and asking them to develop networking tools?
So that was easy for us. I don't know about the rest of the companies out there. So for us, we had some really, really sharp, well, one guy, he's really one of our go-to guys, really sharp network engineer who took an interest in development and just started developing. So we kind of brought him along, and he was the linchpin. Then we hired a front-end guy, like another middle-ish guy, and we just started building around them. And it just kind of blossomed. One thing I didn't mention in the prezo, we're doing a lot of Ansible stuff, but then we're starting to run into the edges of what Ansible can support. So then it's like, oh, we need to use Python to make this API call for whatever to populate the host list. So our engineers started with this, and they learned Ansible, and now they're starting to push the boundaries and starting to do more Python. So then they can much more easily relate to our dev team that builds the full-on tool. So it's kind of a way for both sides to sort of start coming together.
Thank you.
Yep.
Hey, my name's John from LinkedIn. You said that your first deployment was kind of an out-of-band network, and that's a trend that I'm seeing. And I'm just kind of curious if you have thoughts on what hurdles we have to overcome before we can see this in more of like a everyday production environment.
I think it's really just trust and confidence. So if we've been running Arista Cisco for 10, 15 years, we know it inside and out. We have huge lists of syslog alerts, things like that, SNMP things that we do, things to watch out for. So with something as new as this, you just need to get some exposure. You need to get as many switches in the network as possible on out-of-band network, and just start trying them. It's all about risk. The smaller companies I think could probably go faster. Larger companies, it's a little bit bigger ships, slower turn. So it's all about managing the risk.
All right, thanks.
Hi, Michael Sinatra, ESNet. I want to preface my question with two things. One is great presentation. Thank you for that. Secondly, you illustrated a risk of buying a product that's essentially black box router switch and that company being acquired and it being end of life, that kind of stuff. I really like this idea of disaggregated architectures for routing and switching. But my concern is that now you have, instead of one black box that's potentially getting acquired or potentially end of life, you now have 4 or 5 pieces, any one of which could get acquired and quashed. And what is your feeling on sort of the risk of that as compared to the risk of a single black box? And what is your feeling in terms of how does the market look for things like routing engines that run on top of OpenFlow controllers that run on top of OpenFlow switches, or other switches that have open APIs? Do you feel like there's enough backup in each of those links of that chain that you can build a relatively risk-free router that you could hook up to an IX and actually use as your peering router?
Good question. I don't know if anything is risk-free, but we focus mainly on the software. And if our hardware vendors were to get bought out, basically as long as a box is ONI compliant, we know that we can run the software on it as long as the vendor qualifies it. My bigger concern is if the software vendor, say, Cisco bought Cumulus or something like that, and then changed it up, what would you do at that point? If we're focused around basic functionality and we try to reduce the number of features that we're running in our data centers rather than expand, we're really dependent on basic things like MLAG, LACP, and FRR, Quagga, next gen. So we could, if Cumulus got swallowed up, I wouldn't like it, but we could probably run some other thing that was based on those specific functions. So as long as we're building out, and I think that's less of a challenge than the initial big move from a traditional vendor to a white box solution. But good question. And that's something that we deal with. We're managing risk as this time goes. As a manager, I'm expected to manage risk, and if I'm saving this amount of money, great, but if I'm adding this amount of risk, it's a no-go, so. One more question?
Hi, Chris Woodfield, Salesforce. A lot of your discussion, a lot of your presentation had to do with the changes in the management mentality, as far as, you know, there's no conf T anymore, cattle, not pets, all that. Has there been any changes in mindset and operational practice in terms of the monitoring aspect of your network? I realize SNMP is syslog, pretty universal stuff. But you know, has anything else come up that you've had to change your operational practices or your mindset around in terms of running the network once everything's configured?
No, not exactly. So we brought these switches in, and we basically told ourselves these have to run with our older or our traditional tools, whether that's ACS and that or SNMP tools. But what we have done is, you know, gotten them working, gotten the minimum bare essentials working, but now we're looking at what else could we do? Could we use telemetry on these boxes with different vendor flavors, gRPC, something like that? Where do we go next? How can we get better telemetry? Can I get better visibility on microbursts? Is one of the things that I'm interested in our data centers, because our traffic is like this. So it really just depends on your environment, I think. And what you're looking to get out of it. Interface counters and errors, those sort of things, is one of the things that kills us. So as long as we have as good monitoring on when our optics are starting to die or if somebody pinches fiber, then we're good.
Okay.
Thanks. All right. Thanks for having me.